Let's now look at some of these tips and tricks when using a conditional signal assignment to make the model more compact and more readable. So the first thing we're going to do is let's enter our traditional model for this midterm list of having a 3 inputs called XYZ and rows 1, 4, and 7 asserted. And we'll call this system master EX, or master example. And what we'll do is we'll just implement it using the traditional way. And let's go ahead and create a new project so that we can see this kind of from the beginning. So let's go ahead and bring up our folder that we're working in. And the first thing I'm going to do is create a new folder. And I'm going to call it master EX, and I'll call it COND SIG assign. And that'll be my working folder. Okay, and then for this one, what we'll do is we'll grab the test bench from desire to learn. So I'll go ahead and say save link as, and we'll put it in VHDL master save. Okay, and now we've got that, and let's go ahead and fire up model sim. And the first thing we're going to do is do a file new project, and I'll browse to where I'm working, which is my desktop. And so we'll go up here, desktop, VHDL master. Perfect. And I'm going to just call this project all uppercase so I know what is what, leave the work directory the same. Okay, and then we will add our test bench. And you do this procedure every single time you run a new simulation. There you go. And then we'll create a new one. We'll call it master EX. And there we go. Okay, so now we're off and running. And what I'm going to do is I look at my test bench, make sure everything's good to go in there. And then I go ahead and let's enter the VHDL for our master. So master EX is, then we're going to go port, and we got X, Y, Z, mode in, type bit, semicolon, and then our output is going to be F. Its mode is out, its type is bit, we end that, we say end entity. Come down here, we say architecture, and we'll call it master EX underscore arc of master EX is, and we'll go ahead and do begin, come down here, end architecture, and let's see, I always like to get a compile at this point, so I save it, go ahead and compile selected, good to go. Alright, and now what we want to do is type in the conditional signal assignment using the specific way. Okay, so I typed that in as fast as I could, and let's see where we're at. Okay, so at this point I should be good to go, and I should be able to get a simulation running. So let's see, let me move this so you can see what's going on, and I'm going to get this simulation running. So I'm going to go compile all, make sure that the test bench and that we're up and running, and we'll go into work. Go ahead and load the test bench. It'll flash for a while. After it flashes, we'll resize it so you can see it. Okay. And here we are. Okay, so that took a few minutes to get back to where we want to be, but we'll go ahead and add to wave signals in region. But this is, you have to do this every single time. So run this for 80 nanoseconds. And we'll check to make sure it's okay. Looks pretty good, except I want to make a display vector that makes it easier to see. So I'll go ahead and do XYZ. And got that, boom, boom. Delete those. I'm going to change the radix of this to unsigned. And we got an assertion for row 1, 4, and 7. Okay, so that was the traditional way of doing it. Okay, so let's start looking at some tips and tricks. Okay, so first of all, this screen, sometimes when you resize it, these little windows come out of they pop all over the place. So sometimes what I'll do is I'll just move them up here and and it'll expand as you go. And so that's about as good as we can get. Okay, so first thing I'm going to do is a lot of times when you're doing VHDL, you'll want to have a code segment that you want to keep, so you'll comment it out, and copy and paste it, and then comment out what you had so that you don't lose it. So I'm going to start messing around with this, and so one of the things I'm going to do is I'm going to go ahead and copy and paste this, and I'll modify this lower code. Okay. Now when I do that, let me go ahead. Let's see. Okay, so now what I want to do is I want to comment this code out. Well, one of the things you can do in Model Sim is just highlight it, right-click, and say, if you can see that at the bottom, let me move it up so you can see it. So I'm going to go right-click, More, comment selected and it'll actually put comments in front of it, and I can unselect it using the same process. I just go right click, more, uncomment selected. Okay, so now I have, basically I leave that code in there in case I ever want to come back and use it. All right, so one of the a next tip that you can do is notice that we list out every single one of these explicitly, so zeros and ones. One of the things you can immediately do to make this more compact is just use an else clause, a final else clause for all of for one of the values. So for example, why don't we just list out conditions when the input is supposed to be a 1, and then what we'll do is we'll get rid of all these ones, these lines for zeros, and then what we'll do is we use an else clause to assign a 0 when any other code comes. So for example, I just explicitly listed 1, 2, 3 input codes corresponding to rows 1, 4, and 7, and then what I'll do is for any other code I just come down here and I say else 0. Okay, all right, so that immediately that made it way more compact. So I'm going to go ahead and I want to simulate this again. So then this comes up to yet another trick is I saved this thing and I need to compile it. So I go ahead and say compile selected. It was successful, but I have a simulation running. Okay, so typically what you might be inclined to do is to come in and say simulate end simulation and then load the simulation again, but that takes a lot of time and then you have to add the signals back in. Well, one of the things you can do is just restart the simulation, and when you restart it, it'll actually bring in the new version of your design. So to restart it, you come up to this button, you hit restart, and what's beautiful about it is it clears out all your data, it reloads in the objects that it's going to simulate, and it leaves your signals the way that you had defined them. So now when I come back and do this, it's like, okay, it still worked. Okay, and you know, we get the same result. So sometimes you might like just say, you know what, I want to just make sure that this is actually working. So let's move one of the assertions to row 0 and see how fast we can actually move this. So compile selected, wave, boom, 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 and look at what I did. So I moved this, I verified to myself that it's actually loading the new code. Okay, so anyway, that's another little thing that'll speed you up there, so let's put that back to the way it is. Okay, now another thing that you can do with this conditional signal assignment is kind of take on the the approach that you do with selected signal assignments, which is, you know, we have to list all these scalar variables out. Wouldn't it be nice if we made a vector that we could use to actually make this a little bit more compact? So watch what I'm going to do here. I'm going to go signal XYZ bit vector, and I'm going to go, let's go to 3-bitter, so 2 down to 0, and I'm going to create this, and the reason I did that is because, let me move this commented code to the bottom so that you can see what's happening here. So I'm always going to be working right here by the begin statement. Okay, so the reason I want to do that is because what if I came in and said X, Y, Z gets the assignment X concatenated with Y concatenated with Z. And the reason I would do that is because I'm going to actually go into here and put the vector name equals the 3-bit code, and it'll make it even more compact. So let's go ahead, save a version of what we just did below. So I'm going to go ahead and go more comment selected, so I didn't lose that. But now what I'm going to be able to do is come in here and say, let's now look at XYZ as a vector instead of the individual scalars. So immediately this becomes even more readable once I go and start using that 3-bit vector. Okay, so life is good, boom, 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 1, 1, 1. All right, so save that up. Let's make sure we can compile. Compile selected, successful. If I want to run the simulation, I just come in here, I restart it, boom, we're back to normal. Okay, so look at how readable that is, though. That's very much more readable than before. Okay, so what else could we do? Well, you know what else you can do to make this conditional signal assignment even more readable? Let's go ahead and do this. Okay, so let me save my version down here so I'm not losing any of my codes. I'm going to go more, comment selected. I can actually put these on the same line within one Boolean condition by using OR. Okay, so I can say XYZ is equal to 001 or 100 or 100, 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 or 1, 1, 1, and then I can get rid of this. So I can actually have all of these conditions on one line. So now look at this. This is actually getting down. We're only using 2 lines, and this is pretty readable. 1, 4, and 7. So let's go ahead and compile that baby. Compile selected, worked. I come in here, restart, boom, run. Still working. All right, so look at how readable that is. Okay, so this is getting pretty compact and very readable. Now the last thing I want to show you, which is really neat, is wouldn't it be cool if you could use like hex to describe this? Okay, so instead of saying 100, what if we could type in the hex symbol 4? Okay, so it turns out in VHDL, well, in Model Sim and VHDL, you can use hex, and the way that you do it is a symbol would look like this. Let me copy and paste this down here and comment it out. I don't want to lose this. I'm going to go ahead and go, let's see here. I want you to be able to see that, so I'll just do this. Just comment it myself. Okay. What we're going to do is the syntax is like this. So you go X and then you do double quotes and like 4. So what this is this is equivalent to 0 or 0100. Okay. Now, if I came in here and I said I'm going to replace this, what's going to happen? Let me try to replace it with just 1 and tell it it's a hex 1. One of the things that goes on is if I save this, I'll comment that so you can see it. Let's see if this works. Okay, so I save this off and I go compile selected. It gives me warnings. Okay, and you say, what's the warnings? Well, it's going, a hex symbol is 4. Okay, so it's not equal to what you're actually looking at. So it's saying XYZ is 3 bits, but a hex symbol is 4. So in order to get rid of those warnings, what you can do is let's create our internal vector to be 4 bits long. And then what I need to do is I need to create XYZ to be 4 bits. Well, one of the things you can always do with any binary, any set of bits is add a 0 to the front of it, a leading 0, and it won't affect the value. So consider this. What if I concatenated a 0 onto the front of this? Then what would happen is that it would say, hey, this is pretty cool. Now XYZ is a 4-bitter, and I can actually come in here and do my hex symbols as this is now 4. And you always do use double quotes. You don't use single quotes even though it's a single symbol. So I go equals X and then this is 7. And look at this. Look how readable that is. So let's save it. Compile selected. Warnings are gone. Let me go back in here, restart simulation. Boom, boom. And look at it. It worked. So we got it. And check out how readable this is. Look at that. F is 1 when XYZ is a 1, 4, or a 7. And I did it by using all these tips and tricks. Okay, so that'll speed up some of your VHDL modeling and also make something that is more compact and more readable.